All right, welcome to the third video. This is exciting. We're going to go over the solving. It does say in the directions to keep in mind the extraneous solutions, and I'm not going to use the graphing calculator for that part when I do the extraneous solutions. And also keep in mind when taking the even root of a number, you're going to have a plus or minus answer. And the only problem that we have to worry about that with is going to be on 31, because in the exponent, the numerator is an even number. And then it's also going to be an issue when we get to 33 because the exponent's an even number. So I'm going to mark them now so I keep that in mind when I get to those problems. So my job is to solve for x. Most of the problems just have one x. So I only have to get x by itself. So starting with 29, to get the x's to start to join up, I need to get rid of that square root. So to undo that square root, I am going to square both sides. So on the left side, I'm going to square my square root, which cancels out the square root. I'm just left with x plus 42. And then I'll also square the right side, which will give me x squared. And now when I look at this problem, we're back in Unit 5 and Unit 6, and I would like to get x by itself, but when you have more than one type of x, we're going to have to factor. So I'm going to bring the x plus 42 to the other side because I want to keep my x squared positive. So that turns into x squared minus x minus 42. I'm going to use my factoring x, so I'll put negative 42 here and negative 1 here. And then through the factor program, the factors that are going to end up working will be negative 7 and 6. And because it is an x squared and not a number with the x squared, I can go straight to my parentheses. And then my two answers are, at this point, x equals 7 and x equals negative 6. But now what I'm going to do is see if either of them, both of them, none of them are extraneous. So I'm going to start with the 7. So I'm going to take 7 and I'm going to plug it back into the original equation. So I'm going to erase the original equation. And I'm going to be using the square root of x plus 42. So first I'm going to put my 7 in. So when I put the 7 in on the left side, and then I'll put the 7 in on the right side, I'm only going to go with what the calculator says. So in my square root, I can add the 7 and the 42 for 49. And then I would ask myself, will the calculator agree with me that the square root of 49 is 7? It will. So 7 is the solution. And then I'm going to do the same, but this time I'm going to check my negative 6. So I'll put negative 6 in the left side and the right side wherever there's an x. On the left side, I end up with 36, and on the right side, I get negative 6. And the calculator wouldn't agree with that. We would say it is, but that's only when we solve for x. When you evaluate and you plug a number in for x, you go with whatever the calculator says. The square root of 36 is supposed to be 6. So negative 6, although we got it as a solution, we're going to count that as an extraneous solution. Okay? All right. Now what I'm going to do, move that over a little bit, is go to my next problem. On the next problem, again, my job is to get x by itself, but I can't touch the x until the cube root's gone. So to undo a cube root, I'm going to cube both sides. The left side just becomes, excuse me, x minus 7, and the right side becomes 27. And now to get x by itself, I just add 7, and when I'm done, I get 34. So now what I want to do is see, is that extraneous? So I'm going to take the 34, plug it back in, and see, does the left side equal the right side? So if I take the cubed root of 34 minus 7, that's the cubed root of 27. And the calculator would agree with the fact that it's 3. So this works. It's not extraneous. The answer is just 3. 31, here to get x by itself, remember I'm going to have two answers. I have to move the 3, the 1, and the 4/3. I'm first going to move the 3. I'll move the multiplication before I move the exponents because I'm going to work backwards in the order of operations. So technically I'm supposed to move any addition or subtraction, but that x plus 1 is in parentheses. So dealing with that will come in my parentheses step. So first I'm going to move the 3. I'm going to divide those sides by 3. So on the left side, I'm just left with my x plus 1 to the 4/3 power, and 48 divided by 3 is 16. And now to get x by itself, I'm going to get rid of the 4/3 power, which is going to be taken to a 3/4 power. So on the left side, the 4/3 and the 3/4 turns into 12/12 because we're multiplying those exponents, and the 12/12 power is just 1. So x plus 1 to the first power is just x plus 1. And then on the left side, again, you're more than welcome to type that into your calculator. Your calculator will tell you 8, but it's going to be plus or minus 8 because when I do rewrite this as a radical and this denominator 4 becomes the 4th root, since we're solving for x and I take the 4th root of x, or I'm sorry, of 16, I'm going to say positive and negative 2. And then when I deal with the 3, which becomes the exponent, that gives me a positive and a negative 8. So up here I'll be working with both, which at this point I just have two problems. X plus 1 equals 8, and x plus 1 equals negative 8. So either way I'm going to subtract 1, so one answer is 7 and the other answer is negative 9. And now I'm going to check to see which is extraneous. So I'm going to put 7 back into my original equation. So here we go. And I want to see, if I do the math, does it give me 48? So starting with parentheses, that's 8. And then 8 to the 4/3 power on the calculator. 8 to the 4/3 power, it's going to give me 16. And then does the left equal the right side? Yes. 3 times 16 is 48. So 7 is an answer that works. So I can go ahead and put that into my x spot up here. And then I'm going to check negative 9. So this time I'm going to put negative 9 in. So starting here, negative 9 plus 1 is negative 8. And when you type this into your calculator, make sure that you put that negative 8 in parentheses when you take it to that 4/3 power. Because if you don't, it might give you the right answer. So it's supposed to give you a positive 16. And again, 3 times 16, yes, that's 48. So this one works too. So neither answer here is extraneous. They actually both work. All right, let's go to 32. 32 is a problem that has two x's, and they have already for us gotten one x on one side and one on the other. So to start bringing those x's together, to undo those square roots, I'm just going to square both sides. If they had both been cube roots, I would have cubed both sides, or 4th roots to the 4th power. So the left just becomes x plus 3, the right becomes 2x minus 7. I'm going to have the x's join up, and then I'll add the 7 to the other side. So when I'm done, I have x equals 10. And again, I want to check to see if that's extraneous, so I'm just going to plug 10 back into the original equations. So on the left side, it'll be 10 plus 3, and on the right side, it'll be 2 times 10 minus 7. On the left side, I end up with the square root of 13, and on the right side, I end up with the square root of 13, which those are the same, so 10 works. It's a solution. All right, 33. 33, remember we're going to have two answers, and the other thing I want to point out is this negative. This is like having a negative 1 in front of those parentheses, so I am going to rewrite it like that for now. And so first thing, to get x by itself, I'll move any addition or subtraction, so I'm going to be moving this 5. The plus 3 inside is in the parentheses. I'll get that when I get to the parentheses. So I'm going to subtract 5, which gives me negative 4 on the other side. And now I'm going to move any multiplication or division, so I'm going to move the negative 1 by dividing. And that gives me 4 on the right side. And now I'm ready to get rid of this exponent, and it's in this step that I'm going to get my two answers. So when I'm ready to get rid of the 2/3 power, I'm going to use the 3/2 power, which on the left side just ends up with 2x plus 3. And if you type in 4 to the 3/2 power on your calculator, you're going to get 8. But again, this is that plus or minus 8, because technically, if I do rewrite this as a radical, this 2 becomes like the square root, and the square root of 4 when we solve is either 2 or negative 2. Since we don't know, we look at both. And then the 3 becomes the exponent, and that's how I get the plus or minus 8, because 2 cubed is 8, but negative 2 cubed is negative 8. So we now branch off into two problems. In the first one, I'm going to subtract 3, and then I'm going to divide by 2, so I get 2.5. And then I'm going to go ahead and solve for the other one. I'm going to subtract 3. This time I get negative 11, and when I divide by 2, I get negative 5.5. So now I want to see, are these extraneous? So first I'm going to take the 2.5 and I'm going to plug that into the original equation. So here's the negative that was there. 2 times 2.5 plus 3 to the 2/3 power plus 5 is supposed to give me 1. So starting in my parentheses, I'm going to deal with the 2 times 2.5, that's 5. And then the 5 plus 3 is 8. And remember, this is like a negative 1. So when I type in 8 to the 2/3 power, 8 to the 2/3 power is the same as 4. And then I'm going to multiply and I get negative 4. And when I add that to 5, I do get 1. So 2.5 works. I can put that in my answer. I'm going to go ahead and check the negative 5.5. I'm going to do that over here. So here's the negative. I'm going to actually make it negative 1. 2 times negative 5.5 plus 3 to the 2/3 power plus 5, and does that give me 1? So again, starting in the parentheses, I'm going to take 2 times negative 5.5. That's going to give me negative 8. I'm sorry, no, that's going to give me negative 11. And now I'm going to add the 3 to the negative 11. That gives me negative 8. And again, when I take negative 8 to the 2/3 power, put that negative 8 in parentheses. When you do that, you will end up with a 4. I'll multiply that 4 times negative 1. And again, does the left equal the right side? It does. I'll get 1 equals 1. So both of these answers actually work. Neither of them are extraneous. So I can put both of them in here. And let's go to the final one. So on the final problem for the solving, my job is to get x by itself. And when I get x by itself, I need to move the 1/3. I need to move the cube root. I need to move the 8 and the 5. So the first thing I'm going to move is the 5. I'm going to move my addition or subtraction. So I'm just going to be adding 5 up here really quick. So at this point, I have 5 equals 1/3 the cubed root of x minus 8. The next thing I'm going to do is move the 1/3, and I'm going to do that by multiplying by the reciprocal. So if I multiply this side by 3, the 3 and the 1/3 cancel out. So I'm going to multiply this side by 3. That gives me 15. And now to get x by itself, I'm going to get rid of the cube root, so I'm going to cube both sides. The left side just ends up with x minus 8, and the right side ends up with 3,375. But I'm going to add 8 really quickly to both sides, so I end up with 3,383. So now I just want to see, does that work? So for this problem, I'm going to plug that in, and I'm actually going to do that right above the original problem. So if I take 1/3 times the cubed root of 3,383 minus 8, and then subtract 5, do I get 0? So the cubed root of 3,383 minus 8, well, when I do my subtraction, inside the cube root, I get 3,375. And when I take the cubed root of 3,375, I get 15. So here we go. And then 1/3 of 15 is 5, and so 5 minus 5 is 0. That works. So my answer works. This 3,383 is the solution. It's not extraneous. And let's finish up with our 2 word problems. So if you read the word problems, you should actually take a moment to read them. But I'm asked to work with this formula, that velocity equals the square root of 2 times g, which is acceleration due to gravity, and h, which is the distance. So on 5a, where are you on Earth when g is 9.81? Well, if you continue to read the problem, they want you to use the fact that the velocity is going to be 30 meters per second. So I'm going to set it up. I know v, and then inside my square root is going to be 2. I know g, so what I need to do is find h. So the first thing I'm going to do is clean up my inside the square root. I'm actually going to take 2 times the 9.81. And when I do that, I get 19.62. And now I'm ready to solve for h. So the first thing I need to do is get rid of the square root. So I'm going to square both sides. So 30 turns into 900. And the square root is now gone. And now to get h by itself, I'm just going to divide. So I end up with 45.87. So that's your answer for 35A. And then 35B, you're just going to do the same thing, but you're going to use a different number. So my velocity is still 30. I'm still going to have the square root, but this time g is at 1.57. So 2 times my 1.57 times my h. So I'm going to multiply first, clean up inside. And now I'm ready to get h by itself. So the first thing I'm going to do is square both sides to get rid of the square root. And now to get h by itself, I'm just going to divide. And now h is worth 286.62. And that is it for the review.